geobyte.
Dear students, now let us discuss the previous year questions for the very important unit, that is mechanical properties of fluids. Okay, from this very important unit, you can expect two questions for the NEET exam. That is the weightage of this particular important unit for the NEET exam. Okay, I hope all of you clearly understood all the theory concepts what we discussed for mechanical properties of fluids. Understood or not? Yes. Then let us take the very first question, asking like this: an ideal fluid is flowing in a non-uniform cross-sectional tube XY shown in figure from end X to end Y. It is clearly given that the fluid is flowing from end X to end Y like this. Okay. Now it is given that ideal fluid. Assume that ideal fluid is liquid, then density remains constant. Let us write that point. Assume liquid is flowing. Fluid may be, gas or liquid. I am assuming liquid is flowing. Liquid is flowing. Since liquids are coming under incompressible fluids, therefore density remains constant. Density rho remains constant. Density rho remains constant. Okay. Now, if K1 and K2 are the kinetic energies per unit volume of the fluid at X and Y respectively, given that kinetic energy per unit volume at X is K1 and Y is K2, then correct option is you're asked to decide the relation between the kinetic energy at X and Y. Okay. For that, look at the arrangement. Here I can take the elevation X, X is taken as reference point. Therefore, Z1 equal to 0 and this is the Z2. This is the Z2. Z2. Now for deciding the kinetic energy relation for X and Y, let us take the Bernoulli equation. According to Bernoulli equation, according to Bernoulli energy equation, Bernoulli's energy equation, according to Bernoulli's energy equation, some of the kinetic energy, potential energy, and pressure energy at state 1 means at X equal to sum of the kinetic energy plus potential energy plus pressure energy at Y. At Y. Okay. Now it is given that kinetic energy at X is right K1. K1. Kinetic energy per unit volume, of course. That is given kinetic energy per unit volume. The kinetic energy at X is half into M into V1 square, half M V1 square plus potential energy mg Z1 plus pressure energy P1 by rho is equal to half into m V2 square, assuming V1 be the velocity at X and V2 be the velocity at Y, plus potential energy at Y mg Z2 plus P2 by rho. You need not write rho 1 rho 2 because rho 1 equal to rho 2, that is equal to rho for the incompressible fluids like liquid, because we are already assuming liquid is flowing through the pipe. Let us take another slide. It is written half m v1 square plus mg z1 plus p1 by rho is equal to half into m v2 square plus mgz2 plus P2 by rho. Okay. Now it is given that kinetic energy per unit volume dividing by volume on both sides. Dividing by volume on both sides. On both sides. Then it is half into m by volume into V1 square plus m by volume into gz1. Of course, this quantity is becoming 0. Z1 is becoming 0 plus P1 by volume into rho. Of course, rho can be written as mass by volume. Rho can be written as mass by volume is equal to half into mass by volume into V2 square plus mass by volume into gz2 plus P2 by volume into density is mass by volume. Mass by volume. Z1 equal to 0 na, this quantity is becoming 0. Then it is given that kinetic energy per unit volume, the very first quantity is kinetic energy per unit volume, that is written as K1, that is given as K1 plus this volume cancelled, P1 by mass equal to this quantity equal to kinetic energy per unit volume at state 2 plus, right, here it is m by volume, mass by volume is density into rho into g into z2 plus this volume cancelled, p2 by rho, p2 by mass, let me write it clearly, p2 by mass. Then look at the k1 equal to, I can write k2 plus rho g z2 plus P2 minus P1 by m. P2 minus P1 by m. Now, from this, generally, P1 almost equal to P2. P1 almost is slightly, the P2 is more, right? Okay, anyhow, I can say that, by the time the liquid is flowing, kinetic energy, velocity is increasing since V2 is more than V1. Since V2 is more than V1, I can say that V2 is more than V2 is more than V2 less, sorry. Ek minute. Velocity is decreasing because according to continuity equation. What is the continuity equation? Continuity equation, let me write it clearly. Continuity equation is A1 V1 equal to A2 V2. Right? Here V2 equal to what? V2 equal to A1 V1 by A2. Look at the area at y, area is increasing now. By the time the area is increasing, velocity decreases. Velocity decreases means kinetic energy K2 is less than K1. On the other hand, by the time the kinetic energy is decreasing, pressure energy increases. So P2 is more than P1. P2 is more than P1. Now here it is K1 is less than K2 and P2 is more than P1. Therefore, P2 minus P1 by M is positive. Since P2 by P1, right, by M is positive, this is the positive quantity. It is added to rho g Z2, it is added to K2. Therefore, I can say that K1 is greater than K2. That is the relation between the K1 and K2. By the time the liquid is flowing through the pipe, velocity decreases. Velocity decreases means kinetic energy decreases. The drop of kinetic energy is converted to pressure energy. Therefore, P2 is more than P1 because of the more P2 than P1. P2 minus P1 by M is positive quantity. Positive quantity added to rho g Z2. That is right more than rho g Z2. Then K1 plus K2 plus more than rho g Z2. That means we can say that K1 is more than K2. Look at the options. K1 is more than K2. no option is available. So option C may be, it may be printing mistake. K1 is more than K2. K1 is more than K2. That is the relation between the K1 and K2. Then with this correction, I can take option C is absolutely correct. Understood clearly? Yes.
Geobyte.